Hello, we are the IoT Communication Aggregator team. We've built a product called IntelliWatt, and our team consists of Gemma Grover, myself, Jacob Floysand, and Yiju Guo. And here's our contact information. To introduce our product, I'd like to show this visualization from RockyMountainPower.net. So the cost of electricity on this website shows that it costs 8.9 cents normally. But Rocky Mountain Power offers a tiered plan where the users can pay 3 cents when electricity is off peak hours and 34 cents when it's on peak hours. Peak hours are defined by the demand of electricity, or when people use electricity the most. This is good for users, but it can be inconvenient to turn on devices at just the right time. So our product will automate this process by turning on devices when the cost of electricity is lowest, thus saving the user money. What I like about our product is that it monitors the demand itself, so that once the users set up their smart devices, they don't have to worry about doing very much maintenance on like their website or with the devices. Everything is automated, so it's very easy for the user. The home user system consists of all of the devices on the home network. There's a home user website, an electric company website, a remote server which runs in Google Cloud, and MongoDB. I'm going to talk about the home user system, and then Yiju will talk about the home user website, and Gemma will talk about the electric company website. Now, one limitation of our system is that users will need to purchase smart devices in order to allow these devices to be controlled by our remote server. And these devices will need to have our specific software flashed onto them, or the user will need to purchase them with our software on them. Now, with my part, I used DDS by a company called RTI. DDS is a data-centric system, which means that there's a single data bus which is able to propagate information every minute, so that the information that's propagated to the database is always fully up to date and allows for the most optimizations by the electric company and the home user website. Now I'd like to show you some code as a way to explain kind of what the home user system does. I've written this in Java, and I'm showing you a file called runthermostat.java. This is where devices will write their information to the data bus. It's one of the most important files. There are similar files for other kinds of devices. So, to start, here is the constructor, where a user can create a device. Here's where it's passed into the function as an argument, and then we save that as a global variable to be used later by saying this.device equals device. Now I'm going to skip over a lot of lines of code for the sake of time, and I'll show kind of the important parts. Every device on the system is going to have an object called a publisher. The publisher is capable of putting information on the centralized data bus so that the device-specific information can be sent to MongoDB. We have some boilerplate code, and then here we create the publisher. Okay, further, we need to create a variable on the data bus. That's what a topic is. We create a topic which is very similar to a global variable that we update every minute. We say participant, which is a participant on this network. Please create a topic. Here is going to be the name and type. Alright, and then we also need to create a writer, which performs the actual act of putting data on the data bus. Finally, we have an infinite for loop, which runs every minute and updates this object called instance with updated information and writes it to the data bus by saying, writer, please write instance to the data bus, and also take this instance handling variable for in case an error happens. So once information gets propagated to MongoDB, it needs to be processed and handled correctly by the user website. So I'm going to pass it over to Yiju to talk about the user website. Thank you.